So, what problem do we face now? We need to understand how we can take general exponential functions where the base is some positive number, or general logarithms where the base is some positive number, and rewrite them in terms of the natural number e. Now, it turns out that's not too hard. We just need to be clever. Now, how would I know to do what I'm getting ready to do? Well, lots of things have been tried, and these are my two favorite ways of actually showing the conversion. You can learn how to convert these, or you can memorize the formula, or a little bit of both. Okay, so let me talk you through this one. The trick to this, to see the transformation, is to apply two functions to a to the x at the same time. A function and its inverse. Now what we're going to apply is the natural log to a to the x, because a to the x is going to be some positive number, and then we're going to apply the natural exponential. Well, these are inverse functions of each other, so this is just the same thing as a to the x. All is good. Now we're going to use a logarithm property, the property that if you take any log, no matter what the base of an exponential, the exponent comes outside. So this is equal to e to the natural log of a times x. And I put that little dot there to emphasize that. So anytime we've got a general like 4 to the x, we can rewrite it as e to the natural log of 4, which is just some constant number times x. And then we can use chain rule to take the differentiation of this. So that's how we rewrite any general exponential function as a natural exponential function. All right, how about a logarithm? Well, we've got to be a little more clever. There's a couple of ways of attacking this to get what we want, and here's the way I would do it. So the first thing I would notice is what is log base a of x? Well, it's a number that if I raise if I raise a to that number, I actually get just x. Okay, so I write out that identity. The a to the log base a of x is x. These are inverse functions of each other. Okay. Now what do? Well, I'm going to take the natural log of both sides. So this is a positive number, this is a positive number. I can take the natural log of both sides and they're the same number. And I'm going to now apply the same rule I just applied up here. I'm going to say, look, I'm taking the log of a number to a power, so I can bring that power down. So let's bring it down. And I'll have left over just a, because bring that down, so I've got the natural log of a, something we saw up here, times the log base a of x, the thing that we were trying to rewrite, is equal to the natural log of x. Well, dividing through by this constant number, we get that the log base a of x is equal to the natural log of x over the natural log of a. That's nice. So we've got these two identities. A to the x is e to the natural log of a times x. Log base a of x is natural log of x over natural log of a. Let's at least look at this a little bit and see if it makes sense visually. So I'm going to reduce the magnification here. So let's plot, very good, Todd. Let's plot, let's see, log base 2 of x and see what we get. And let's go from x being 0 to, I don't know, 2. And let's not set the range, let's let them. Okay, so there we go. Looks like every other logarithm, right, of a number bigger than 1. So log base 2 of x looks like that. Now let's plot that along with just the natural log of x. When you don't put any base in Mathematica on the log function, it assumes it's base e. I could actually write in base e comma there and it'd be the same thing. So let's plot that. Now Mathematica, the first function is always blue, and the second function is always maroon unless you tell it otherwise. Well, it looks like a logarithm, but it's just a little bit, it's a little higher here and a little lower there, but it turns out that it's different only by a factor. Because look what happens. If I take the natural log of 2 and divide this function log of x by it, now we just saw that we had an identity. The log base a of x is equal to natural log of x over the natural log of a, and here I'm using 2. So what I should get when I plot this is just one curve. All right, so let's see what we get. And lo and behold, it kind of looks like a blue maroon curve on top of each other. If I just change this ever so slightly, we can see, well, even that much, it doesn't change that much off. Let's try the base a little bit different. There it goes. So if I take log 2.1 instead of log 2, dividing by that constant, it throws that off just a little bit. So we're kind of visually verifying that this identity works for one case. Beautiful stuff. Hope that helps.